Okie dokie. Test prep questions for the first half of chapter 9. So we are looking at questions from 9.1, 9.2, and 9.3. All right, so looking from 9.1, this was the inverse variation. And the directions here say suppose that x and y vary inversely. Well, then that tells us that we have y equals k over x. Or to find k, you have x times y. Okay, but this is the inverse variation model. So write a function that models each inverse variation. Let's do number 5. All right, so then we have k equals 1.2 times 3. So then the k is going to be 3.6, and then the function would be y equals 3.6 over x. And this would be your official final answer. Right. From the 7 through 12 section, we have 2 questions. In this one, you had to determine if it was a direct variation, an inverse variation, or neither. And the direct variations are written as y equals kx, and you find k by doing y divided by x. The inverse variations are y equals k divided by x, and so then you find k by doing xy. All right, so multiplication was always my easiest, as I said in class multiple times. So let's take a look at number 9. So you have 0.5 times 1, which would give you 0.5. 2.1 times 4.2 is not going to give you 4.5. So back to the drawing board, it's not an inverse. So now let's try y divided by x. So that's 1 divided by 0.5, which is going to give you 2. 4.2 divided by 2.1 is going to give you 2. 7 divided by 3.5 is 2. And 22 divided by 11 is 2. Just because the first two are the same doesn't mean you stop. You have to make sure that the constant of variation is the same completely throughout. And we got this by doing division. So this one is a direct variation, which means that you have y equals your k, your constant of variation, which is 2. So you have y equals 2x. Okay, so that's how you would do these. Let's see. 13 through 15, there's a question from here. And this one is, suppose that x and y vary inversely. So then you know it's y equals k over x. So to find k, you have x times y. Write a function that models the inverse variation, and then find y when x is 10. All right, so let's do 13. Okay, so then my k is going to be 20 times 5, which is 100. So then putting this in for the k, for the constant of variation, you have y equals 100 over x. And then it says find y when x is 10. So then you have y equals 100 divided by 10, which is just 10. So then this would be your answer for number 13. Okay. From the describing the combined variations, there are going to be 2 questions. Remember, you don't describe the numeric value or a representation of a numeric value. So in like number 20, you're not going to say anything about that pi because pi is representing a number. The pi is your constant of variation. So 20 would be v varies, please excuse my printing, varies, and since you're multiplying, you can say directly with the square of r and h. and I paused there for a minute because it probably should have been directly with the product of the square of r and h, or varies jointly. Okay, so jointly would actually be better because that's implying that you have a direct product. All right, let's take a look at 21. So 21, you would have h varies directly with v, and inversely with the square of r. All right, let's take a look at the next one. 2 questions from this section. Let's do 26. I think I did 24 and 25 separately for 2 different classes. So z varies directly with the square of x and inversely with y. Okay, now with these, remember, just like we had from back here where we did not talk about the constant of variation, they are not talking about the constant of variation. So looking at number 26, it says z varies directly with the square of x, so that's going to be x squared, all over inversely with y. But you have to have a k here, so kx squared divided by y. Now they give us that x is 2, y is 4, and z is 3. Well, they give us those 3 so that we can substitute that in and solve for k. So let's do that. Z is 3, k we don't know. Then you have x, which is 2 squared, all over y, which in this case is 4. Okay, so 2 squared is 4, so 2 squared over 4 simplifies to just 1. So then you have 3 equals k. So now that goes into this variation, and we have z equals 3x squared all over y. Right? And then that is the function that models that variation. But then we're told to find z when x is 4 and y is 9. So we need to plug in 4 for x and 9 for y. So then you have z equals 3 times 4 squared all over 9. 4 squared is 16. 16 times 3 is 48. So then you have z equals 48 over 9, which actually reduces to be 16 over 3. Okay, so this answer would be perfectly acceptable. You would need to have this because that is your function that models the variation, and then you would need to have the 16 over 3. All right, then the last question from the 9-1 section is going to be each pair of values is from an inverse variation. Okay, so that tells us that it has the same k. So if we have an inverse variation, we know it's y equals k over x. To find that k, it's x times y. So if it has the same k, then you know k equals k. So then xy equals xy. All right, so let's take a look at number 46. So you have 9 times 5 equals x times 3. So then that's 45 equals 3x. You divide both sides by 3, and x is 15. Take a look at number 44. So we have 2 times 5 equals 4 times y. So 10 equals 4y. Divide both sides by 4, and you end up with 5 over 2 equals y. All right, so pretty easy, hopefully. That was a good refresher. I'm going to go ahead and pause the video now or stop the video now so that it kind of keeps it down as far as time goes.